Welcome to Biota.org Interviews. I'm Tom Barbalet, and today I have the pleasure of talking with Mark Bedau, who amongst other things is the Professor of Philosophy and Humanities at Reed College, the Adjunct Professor of Systems Science at Portland State University, the Editor-in-Chief of MIT Press's journal Artificial Life, and the COO of a startup company in Venice called Protolife. For people not familiar with your background, please give some discussion to how you became interested in artificial life.
All right. My professional background was in philosophy. I have a PhD in philosophy from Berkeley. And when I was studying philosophy as a graduate student, in fact, I was interested in living systems and complicated systems, hierarchical systems. I was interested in how complexity arises, how you get something from nothing. I was also interested in some other questions about the nature of mind, etc. And that was in part because this connected interest in the nature of complex systems. But I found it very hard to make progress on those questions. There are a number of people who had written about them, but some philosophers, some scientists, but it seemed like it was no one was getting much traction. So I left that topic aside and worked on something else, which was the nature of biological teleology, or purpose, and then started a normal philosophical academic career. And in the first 5 or 6 years or so, I started to hear about a group of people who were starting a movement called an intellectual community called Artificial Life, and I was interested because they were interested in the nature of life and living systems and complicated systems, and they actually invited me to come and give a talk about what I thought biological teleology was, because that's one of the hallmarks of living systems, and it's hard to understand what life is, and they thought that maybe they would learn something if they asked a philosopher to come out and talk about teleology, and at worst what they would do is just waste an hour. So I went out to the Santa Fe Institute when it was just being started, and also went up to Los Alamos on the same trip to talk to the Artificial Life group there. And I knew that from talking with these people before that they thought that they did not understand someone's theory unless they knew how to simulate it on a computer. And I had never thought about how my view of biological teleology would look if it were simulated on a computer. I'd talked and written about it to philosophical audiences for a number of years. So at the end of the talks I gave, though in this context, for the first time I added an appendix about how my view would look if you were to simulate it on a computer. And after my talk, someone came up and said, we could do what you were talking about in this model I've got very easily. And so we stayed up that night and figured out how to do it and thought about what the implications would be and imagined what the results would look like. And then the next morning, in about half an hour, I implemented it, and then got some preliminary results, and they were incredibly interesting to me, because this theory of teleology that I'd had in my mind and been thinking about and talking about and writing about for many years came alive in front of me, because I could see the consequences of working out the details of that view in a way that I'd never been able to do before. That was because the computer was like a prosthetic device for our imagination, and so I got hooked, and I decided I'm interested in the same questions and I still want to pursue them, but I want to use this methodology too. I want to add this as a tool that I have in my toolkit. And furthermore, from talking with these people, I realized that there were a lot of what I consider to be philosophical questions that they were dealing with. They were trying to understand the fundamental features of, or the essential features of living systems, and that's the kind of question that a philosopher asks. The philosopher wants to know the essential features of, what it is to have a mind, or what it is to be ethical, what it is to be a cause, etc. And further, so they felt that since the questions were so foundational, they felt familiar to me as a philosopher, and they were familiar to the questions that I've been thinking about or been trying to find a way to answer for many years. And also, there were other philosophical questions that were generated by their activity that I thought philosophers were, well trained to answer. The most salient example was the question of whether a computer model or a computer system that's exhibiting lifelike properties could ever literally be alive. This is analogous to the question of whether a suitably programmed computer could ever literally think. That's a question about artificial intelligence, and there's an analogous question about artificial life. And it was exciting to me to think about that because I'd been interested in artificial intelligence through my interest in philosophy of mind. And the question about whether computers could think is a very hard one to answer. It's very controversial. And I thought that it was similar to the analogous question about artificial life, but it might be able to be answered much more readily in the context of life because life was simpler than mind, I thought. So so since then I've just been spending half of my time roughly doing artificial life-like activities, sort of science-like activities, studying computer models mainly for the following 15 years, and then most recently I've gotten involved in moving out of not just looking at computer models of evolving systems and the like, self-organizing systems, but also trying to take these ideas and instantiate them in a wet laboratory. So that's how I got involved and why I'm interested. I see philosophy and artificial life as natural intellectual partners. One of the main methodologies that philosophy uses is thought experiments. You ask, what if so-and-so were the case? What would follow from this? You can see philosophers developing and using that methodology all the way back in Plato, and they still use it today. And I think of artificial life experiments as thought experiments that are implemented with the help of a computer or some other synthesis device. When you're asking questions about complicated systems that are complicated and adaptive at the same time, it's very hard just sitting in your armchair like philosophers traditionally do to figure out what the consequences of the scenario you're envisaging would actually be. And so putting it on a computer or creating it in a laboratory or building a system, a robotic system, a hardware system that implements those ideas, and then stepping back and observing it is, in many cases, I think the only practical way to really see what the consequences of those imagined scenarios would be. There are other questions, philosophical questions, that are connected with, intrinsically connected with the artificial life endeavor. The nature of life is one. I'm very interested in the question of the nature of life. The connection between life and intelligence, or life and mind, is another. The nature of emergence is a third. I'll just end with maybe one more that has a lot of interest to me today, and that's the question of how evolution could possibly be as creative as it is. If you think about the biosphere that exists right now and remember where it came from in the primitive forms of life, it's astounding. It's really incredibly striking that a extremely diverse and complicated biosphere with all kinds of extremely complicated organisms in them, as well as a bunch of extremely simple organisms, arose out of a system which arose spontaneously through natural processes out of a system that had just a few very simple organisms. So that's what I mean by the evolutionary creativity that is exhibited by the evolutionary process. And so the question is, what is it that enables any system to exhibit that kind of evolutionary creativity? And this is something that philosophers have thought about, speculated about, scientists have thought about and speculated about, and I think it's still an open question, and one of the holy grails, in fact, in the artificial life community. So I think of philosophy and artificial life, science in general, as being natural partners, and especially when the science is concerned with foundational issues, as artificial life is these days.
Now, the A-Life conferences have been going on for about 20 years, and they occur every 2 years. Could you please characterize the conferences and discuss the highlights over the recent conferences?
The trip I was just mentioning that I took to Santa Fe, the Santa Fe Institute in Los Alamos, occurred just after, the week after the second Artificial Life conference. So I didn't go to the first one or the second one, although I heard about them. And they were very diverse conferences. They had people from all over the intellectual landscape coming and sort of finding each other, finding that there were other people that were interested in similar questions. And there was a kind of I gather they had a quality almost like a little bit like a party. And the more, as conferences have gone on and on, two main things have happened. One is that they've become a little bit more conventional, so that right now there's a routine of them happening every 2 years, and you see a lot of incremental progress happening. And in the early days, it's incremental progress. It was bold new attempts to answer questions, and people really much more pioneering work. So now it's much more a matter of incremental progress, and in some ways that's a shame, because some of the excitement of the original conferences is not there any longer. But in another way, that's a good sign, because it's a sign that the activity is maturing, and there are questions that you can, and methodologies that you can make incremental progress with. I think another set of highlights, there are a couple of things I'll mention. One is that there is no longer just an artificial life conference. I mean, there is an artificial life conference that happens 2 years, but there's also now a European conference on artificial life that happens in every other year in alternate years. There's a Japanese conference in artificial life and robotics that happens every year. There's an Australian conference in artificial life that happens every year or 2 years, I forget. There's now an IEEE conference in artificial life that's happening for the first time this year. So you can see that there's a burgeoning activity of more and more artificial life conferences springing up around the globe, so that the seed has taken root and is spreading. And if everyone who goes to all of those conferences were to just go to the one conference, the Artificial Life Conference, it would have grown in size from the original conferences probably by by a factor of 5 or maybe 10. I'm not quite sure. The other highlight in my mind is that the following thing. In the original conferences, most of the work, the vast majority of the work, 95, 97, 98.6% of the work in the original conferences was involved software. And let me step back and say that I think of artificial life, and I think Chris Langton, when he was originally creating the phrase and founding the journal of artificial life, thought of artificial life in the same way, and that's as follows. It's the attempt to understand the essential features of living systems by synthesizing those systems in artificial media. So what are the artificial media that people use? There are 3 main media. One is software, building software systems. That's what I refer to as soft artificial life. Then there are those who use hardware, silicon and steel and other materials like that, to build systems, robotic systems that are based on life and attempt to understand living systems. That's what I call hard artificial life. And then there's also an attempt of people who use biological laboratories, biochemical chemistry laboratories, wet labs, to create systems in test tubes that are lifelike, and I defer to that as wet artificial life. So in the initial conferences, almost all of the activity was soft artificial life, and there was some hard artificial life that slowly crept in. And now you see lots of hard artificial life at these meetings, and you now start to see more wet artificial life. There was very little, almost no wet artificial life at the original conferences, virtually none. And now you certainly see some. At the last conference, there were certainly a handful of people doing wet artificial life. And I think what this shows is the following: it's much easier to make a new system if you're just creating it out of software. If you're creating it out of hardware, it's harder because there are all kinds of practical problems that you have to confront. And if you're creating it out of wetware or trying to have it create itself, self-organize and self-assemble out of wetware, that's even harder still. There's just a lot of time that has to be spent in the laboratory working out all kinds of dreidely details that with software you don't have to worry about. So we're now mature. The field has matured to the point where there is some significant progress happening on the hard artificial life front and the wet artificial life front. And I take it again. I think of this as just another sign of the increasing maturity of the endeavor.
Leading into that, the journal Artificial Life is a phenomenal publication with a prestigious editorial board. With the expanding kinds of artificial life development being done currently, do you foresee the editorial board dividing into specialist groups, or do you like the broad surveying that appears to exist in the current editorial board?
I myself like the broad survey that exists in the current editorial board, and I hope that the journal will keep that breadth of focus, because I think it's important for there to be a place where where people with a variety of different approaches can come together to read about work and discuss ideas that are connected in the way in which those broad ideas are connected. In other words, I think that there's something to be learned from people people working in soft artificial life and talking with people in hard artificial life and talking with people in wet artificial life, for example. That's one division. Furthermore, people who have sort of interested in the philosophical questions about artificial life, for them to be engaged in a really concrete and constructive way with the people who are working in these other fields as well. So I hope that there will be a journal, let's say it's the Artificial Life Journal, that keeps that broad focus. I think as things mature and develop, it will be natural if there are other more specialized journals that are spun off with more narrow focus. And this is already happening. You can see, for example, a good example might be the Evolutionary Computation Journal and the Genetic Programming Journal. I think in the very beginning, that work, evolutionary computation, genetic algorithms, evolutionary genetic programming, and the like, that work was surfaced first at artificial life conferences and was published in artificial life journals, and then now it's a standalone activity. They have their own conferences, they have their own journals, and in some ways they've to the extent that those endeavors have become purely engineering activities without an attempt to understand or contribute to our understanding of the nature of living systems, I think it's appropriate for them to veer off and have a separate activity. But to the extent that those activities are still having the potential to illuminate the nature of living systems and exploit in distinctive ways the power of living systems in their engineering activities, then I think it would be appropriate for them to to keep a connection with the artificial life broad tent. So I think that there will be further spin-off activities like those, and which are now, as I said, some of the evolutionary programming, evolutionary computation conferences are significantly larger than the Artificial Life Conference right now. And they happen on roughly the same time scale. Maybe it's even every year. I don't know. And so I think that's natural, and I think that'll continue to happen. And but as I said, I think it's important for there to remain a journal with the broad focus that we have now, and also a conference with the broad focus that we have now, and we'll see whether that happens.
Brig Kleiss launched his Evolution Prize at A-Life 10. What are the benefits of the Evolution Prize for artificial life developers, and what's your own thinking on the prize?
I have a couple thoughts about the prize. I talked with Brig about this, his ideas about the prize, I think first back in 2001 or something like that. So I'm glad that it's moving forward. I think there's a positive. I have some things positive to say, and then some things that are some worries that I have. First, on the positive side, I think that having a prize is a great way to galvanize people's attention and focus their attention in a constructive way. And I think that the question that he wants to associate with the prize is directly related to the issue of evolutionary creativity that I mentioned a little bit earlier, which I mentioned that's one of the holy grails of artificial life. So I think having a prize, a substantial monetary prize that's associated with progress on that would be a good thing. The worries that I have are that it's tricky to administer this in a constructive way, in an appropriate way. It's very hard to judge progress on the prize. And that's one of the reasons why, although I originally discussed this idea when Brig got in touch with me back in 2001, why it took at least 5 years for it to move forward. Partly that I was busy and didn't have time to really help him, but also I didn't see an easy way to do it. And I'm not. I'm still interested to see whether the current framework is going to be to deal with the practical questions of administering the prize in an appropriate way. But I like I hope the prize succeeds. I think it's a good idea if it's done well. Some people at the last Artificial Life Conference, where this prize was discussed and announced, were concerned that it would raise the attention of creationists or intelligent design folks who are critical of evolution, and that we shouldn't have the prize. I don't share those concerns. I think that for various reasons. One is that I think there are fundamental open questions about evolution that we don't understand right now, and the central one I've been talking about is the creativity of evolution. And it's fair for creationists to bring that up and point out that we don't have there are open questions that are fundamental about evolution. That's one of the ones that they like to pick on, and to pretend that we understand the answer when we don't, I think is intellectually dishonest and doesn't serve us in the long run. Of course, I presume, as do all of us, that there is going to be some kind of naturalistic answer to the question, and I think that we'll find the answer to that question, but I don't think we'll find the answer to that. We'll find it eventually, and I don't think it'll take 100 years. I think it'll take 5 years if people focus on it. But I think we won't find the answer to that question, which is one of the really deep and interesting questions about nature, if we pretend that we already know the answer.
Now, talking about proto-life, programmable artificial cell evolution. This is obviously artificial life as wet artificial life. Can you discuss a little bit more about the company and what the broad and long-term aims of the company are?
Yeah, the company was created a little over 2 years ago in Europe in order to participate in a very large European research project that was funded by the European Commission. That project is called, as you mentioned, Programmable Artificial Cell Evolution, or PACE. And there are something like 16 European partners who are participating in it, and the total monetary volume is on the order of $10 million spread over 4 years. And Protolife, in Europe, they like to have small companies, startup companies, involved in their research projects because it gives them more confidence that the research that's being funded will not just be blue sky research, but it will be more likely to have some practical benefit for the rest of society. So we created this company in order to capture some of the intellectual property that would be generated by the project. The long-term aim the aim of the research program was to create a new kind of technology that would enable in the future, at some point in the future, artificial cells to be created in the laboratory. These would be freestanding molecular assemblages that spontaneously organize themselves and separate themselves from the environment and extract material and energy from the environment in order to grow and to reproduce and ultimately to evolve and to perform other functions besides moving around, sensing chemicals, processing chemicals, doing useful things like maybe ultimately in the long-term future, like potentially cleaning up the environment or potentially being the foundation for a new kind of information technology, a new generation of living information technology. So the company's role, Protolife's role in this project was to, so as I said, let me back up a second. The company's long-term goal was to be participating in this aim of making new forms of life from scratch, simple forms of life from scratch. But that would happen if it were to, when it happens, it'll be some point far in the future, 10 years, who knows, something like that. And so we're not banking the company's whole success on creating artificial cells because it won't happen for a number of years. When it does happen, we think there'll be all kinds of beneficial applications of these things. But in the short term, we have to find another way to make money. And that's the following. So let me, again, explain what role we're playing in the project, in this European project. In the European project, what Protolife's role is to develop a way of programming complicated chemical systems. And, these complicated chemical systems that exist in laboratories, you can't program using an ordinary programming language like C or something like that, or Java. So the question is, how can you make a complicated chemical system that exhibits the functional characteristics that you desire? This is difficult because complicated chemical systems are because they're complicated, and it's very hard to predict how they're going to behave like any other complicated system. So the idea we're pursuing in the company, Protolife, is to use methods like evolution in order to design complicated chemical systems. Remember that the evolutionary process is, after all, the way in which the life forms that exist on the Earth were designed. And they are extremely complicated, or some of them are extremely, in fact, all of them are very, very complicated, highly modular. They process information autonomously. They adapt spontaneously to changes in the environment. And it's very hard to design systems like those, especially in a chemical realm, from first principles. And so the idea we have is, again, to take a page from nature and use an evolutionary process. What does that mean? What that means is we have a population of experiments, a population of chemical systems, and we apply some kind of selection criterion to them. We have some way of measuring how much those systems are like the systems that we want to have, and then we take the ones that are, the best measured by that criterion, and throw away the rest, and then the ones that we selected, we create a new population of systems that are like those, but perhaps where some of the chemical details are modified by a quote-unquote mutation of some kind. And then we have a second population, and we apply the selection criterion again, and then we iterate this whole big loop by selecting and then creating a new population again and again and again and again and again. So in our laboratory, what you'll see are what are called high throughput experiments taking place. That is to say, experiments that are happening. We have these multi-well plates with 96 or 384 experiments happening simultaneously, and they're all being this is a population of experiments. They're all being processed together. They're all being screened for their fitness together, and then we iterate this as fast as we can using algorithms that take the fitness measurements that we make and use those to determine what the chemical recipes for the next population of experiments will be. And so that's the methodology we're developing, and we're doing it because we think it's the only practical way in the long term to make complicated chemical systems that have the properties of life. However, today there are other industries that are involved in making complicated chemical systems that are not alive but are doing other things. And one example is the pharmaceutical industry. Another example is the materials discovery industry, the industry that invents new catalysts, for example, or new kinds of lubricants, etc., new kinds of metals. And in many of those cases, those industries are dealing with chemical systems that have many different ingredients that interact synergistically. So they're very complicated chemical systems, and they want to screen large libraries of these complicated chemical systems to find good ones, and that's exactly the domain in which the methods that we're using can be applied. And so we're talking with materials discovery companies, we're talking with pharmaceutical companies about whether our technology could be used to solve their problems today, to help them to do a better job of designing complicated chemical systems through high throughput experimentation using sophisticated stochastic learning algorithms like genetic algorithms.
You've already touched on this through the interview so far, but what more would you like to see from the artificial life community?
One of the main things I'd like to see in the near-term future is for the artificial life community to have success in mainstream science, to become seen as part of mainstream science. One sign of this would be to have more of our the work that's being done in artificial life be published in mainstream scientific journals like Science and Nature. In fact, some of the work that's happening in artificial life is now being published in those journals and PNAS, etc. But relatively, it's relatively rare. So that the idea would be that the work that's happening in this field, I think, is right now one of the, it's a well kept secret, and I wish it weren't so much of a secret. One of the signs of success in this would be if it were easier to get research in this area funded. Right now, it's extremely hard to find, governmental agencies that will fund this kind of work. So I think that's one of the main things that I would view as success. And so, in a way, you could see, you could put my point the following. This is slightly tendentious and not exactly true, but it captures some of the feeling of what I mean. I think the sign of success of the artificial life community would be if the community disappears, because it no longer needs to exist, because it doesn't need to have a special home where it can exist. It'll be just part of the regular scientific milieu.
Any final thoughts for the interview, Mark?
Nothing other than it's been fun to talk with you about this. I think that the field is vibrant and alive and going in new directions, interesting directions, such as there's more and more activity in wet artificial life, as I mentioned before. And I think that in the next decade, that's going to be a particularly exciting area of activity, wet artificial life. So yeah, it's been a pleasure talking with you, and I look forward to seeing some of your listeners at the conferences.
Many thanks for the opportunity to interview you.
Thank you.